students, myself, Henasha, Assistant Professor at LG Institutes of Engineering and Technology. Today, we are going to begin a new topic named Indeterminate Forms. So, let us begin with its introduction. In mathematics, several things cannot be explained by logic and by words. That things are either known as undefined or undetermined quantities, like the form 0 by 0, which is known as an indeterminate form, right? Now we know that the limit of the quotient of two functions fx and gx can be written as limit x tends to a f of x upon g of x. That will be equal to limit x tends to a f of x upon limit x tends to a g of x, provided limit x tends to a g of x not equal to 0. Now, if limit x tends to a g of x equals to 0, then the given result does not give any information about the limit. Next, we will study indeterminate form of the type 0 by 0. So, if limit x tends to a f of x is equal to 0 and limit x tends to a g of x is equal to 0, then limit x tends to a f of x upon g of x, our quotient function, is known as an indeterminate form of the type 0 by 0. For example, limit x tends to 1, x square minus 1 upon x minus 1. If we start evaluating this, that is, if we put x is equal to 1 in the numerator and denominator, then we will get indeterminate form 0 by 0. Same way, limit x tends to 0, cos x minus 1 upon x square. Suppose if we put x is equal to 0 in this, we will get cos 0 minus 1 upon 0. But cos 0 is 1, so 1 minus 1 upon 0. So this is again indeterminate form 0 by 0. Okay. The other indeterminate forms are infinity by infinity, 0 into infinity, infinity minus infinity, 0 raised to 0, infinity raised to 0 and 1 raised to infinity. So in all there are total 7 types of indeterminate form. So today we are going to study the first form, that is 0 by 0, and the working rule for it, and that is known as Lecpitals Rule. Okay, so we will begin with its statement. If f of x and g of x are two functions of x which can be expanded by the Taylor series in the neighborhood of x is equal to a, and if limit x tends to a f of x is equal to f of a is equal to 0, and limit x tends to a g of x is equal to g of a is equal to 0, then limit x tends to a f of x upon g of x will be equal to limit x tends to a f dash of x upon g dash of x if g dash of a not equal to 0. That is what we have to do. We have to do the derivatives of f and g separately and then evaluate the indeterminate form. So let us begin with its proof. Using Taylor series and by assuming validity of power series expansions of f of x and g of x in powers of x minus a, we will get limit x tends to a f of x upon g of x will be equal to. Now we will put the Taylor series expansion of f of x and then g of x. So Taylor series expansion is given by f of a plus x minus a into f dash of a plus x minus a whole square upon 2 factorial f double dash of a plus and so on. Similarly, write the series expansion of g of x, that is equal to g of a plus x minus a g dash of a plus x minus a whole square upon 2 factorial g double dash of a plus and so on. Now we are given that limit x tends to a f of x is equal to f of a is equal to 0 and limit x tends to a g of x is equal to g of a is equal to 0. So here these two quantities will go to 0. So what will remain? So finally limit x tends to a f of x upon g of x will be equal to limit x tends to a, x minus a f dash of a plus x minus a whole square upon 2 factorial f double dash of a plus and so on upon x minus a g dash of a plus x minus a whole square upon 2 factorial g double dash of a plus and so on. Now what we will do? We will take out x minus a common. So taking out common and cancelling these two, what we will get? Limit x tends to a f dash of a plus x minus a upon 2 factorial f double dash of a plus and so on upon g dash of a plus x minus a upon 2 factorial g double dash of a plus and so on. Now we will put x is equal to a in numerator and denominator. So all these quantities will go to 0. So what will remain? F dash of a upon g dash of a. So finally we have proved limit x tends to a f of x upon g of x is equal to limit x tends to a f dash of x upon g dash of x. Now for our convenience we will use the following standard limits for evaluating the following indeterminate forms. Right, so first is limit x tends to 0 sin x upon x is equal to 1 and limit x tends to 0 tan x upon x is equal to 1. Next, limit x tends to 0 e raised to x minus 1 upon x is equal to log a and limit x tends to 0 e raised to x minus 1 upon x is equal to log e to the base e. So that will be equal to 1. Next, limit x tends to 0. 1 plus x whole raised to 1 upon x will be equal to e. Very important identity. And limit x tends to infinity. 1 plus 1 upon x whole raised to x will be equal to e. So all these limits can be evaluated using our Lecpitals rule. So let me give you a brief idea about the limit of limit x tends to 0 sin x upon x, right? So if we put 0, it will be equal to sin 0. So it will give us answer 0. If we put 0 in this, again answer is 0. So which is the form? It is 0 by 0 form. So we have to use our Lecpitals rule. So what we have to do? We have to do the derivative of the numerator and denominator separately. So the derivative of sin x will be equal to cos x and derivative of x will be equal to 1. Now we will put the limit again, that is x is equal to 0. So you will get cos 0 upon 1. But the value of cos 0 is 1. So 1 upon 1. So finally our answer is equal to 1. So we have proved that limit x tends to 0 sin x upon x is equal to 1. Similarly, using Lecpitals rule, you can prove all the 6 standard limits. Now let us begin with the first example. That is, we have to evaluate limit x tends to 0 e raised to x plus e raised to minus x square minus 2 upon sin square x minus x square. So let us start with the solution. Firstly, we will assume L is equal to limit x tends to 0 e raised to x plus e raised to minus x square minus 2 upon sin square x minus x square. Now we will put x is equal to 0. So what you will get? E raised to 0, that will give us 1 plus e raised to 0, so 1. If we put 0 in x square, it will go to 0 minus 2 upon sin square 0 minus 0. So what you will get? 0 by 0 form, because sin 0 is 0. So we have to apply our Lecpitals rule. So start doing the derivative of the numerator and denominator separately. So derivative of e raised to x will be equal to e raised to x. Derivative of e raised to minus x will be equal to minus e raised to minus x. Derivative of x square, that will be equal to 2x. Derivative of constant, so it will be equal to 0. Now derivative of sin square x, so it will be 2 sin x, and applying chain rule into cos x. So finally what you will get is equal to sin 2x. So sin 2x, and derivative of x square will be equal to 2x. Now again put the limit x is equal to 0. So again you will get answer as 0 by 0 form. So apply the Lecpitals rule. Again, so do the derivative of the numerator. So what you will get? E raised to x plus e raised to minus x minus 2 upon derivative of sine 2x will be equal to 2 cos 2x minus 2. Again, if you put x is equal to 0 in numerator and denominator, you will get 0 by 0 form. So again apply Lecpitals rule. So on applying Lecpitals rule, you will get L is equal to limit x tends to 0 e raised to x minus e raised to minus x upon minus 4 sine 2x. Similarly, if you put x is equal to 0, you will get 0 by 0 form. Again apply Lecpitals rule and do the derivatives. So it will be equal to e raised to x plus e raised to minus x upon minus 8 cos 2x. Now if you put x is equal to 0, you will get 1 plus 1 upon minus 8 cos 0. So what you will get? 1 plus 1 upon minus 8 because the value of cos 0 is 1. So finally you will get answer as minus 1 upon 4. In short, you have to apply Lecpitals rule simultaneously up to you get the finite answer of the limit. Now let us solve one more example. That is, we have to evaluate limit x tends to 1 x raised to x minus x upon x minus 1 minus log x. So firstly, we will assume L is equal to limit x tends to 1 x raised to x minus x upon x minus 1 minus log x. Now firstly put x is equal to 1. So you will get 1 minus 1 upon 1 minus 1 minus log 1. So you will get answer as 0 by 0 form. So start applying our Lecpitals rule. So what you will get? Limit x tends to 1. Now we know the derivative of x raised to x will be equal to x raised to x into 1 plus log x. So here put that. Now derivative of x will be equal to 1. Derivative of x again will be equal to 1. Derivative of constant will be equal to 0 and derivative of log x will be equal to 1 by x. Again put x is equal to 1. So you are getting 0 by 0 form. So apply your Lecpitals rule again. Now but in this you have to apply u dot v rule to simplify the derivatives. So you will get limit x tends to 1. Keep x raised to x constant. So derivative of this will be 1 upon x. Plus now keep 1 plus log x as constant and do the derivative of this. So it will be equal to x raised to x into 1 plus log x. Now derivative of 1 will be equal to 0. Keep minus as it is. Derivative of 1 by x will be equal to what? Minus 1 upon x square. So finally you will get minus minus plus and 1 by x square. Now if you put x is equal to 1 and simplify, you will get the answer of the limit as 2. Now similarly, let us solve one more example, that is limit x tends to 0, tan square x minus x square upon x square tan square x. Very important sum. Let us start with its solution. So assume L is equal to limit x tends to 0, tan square x minus x square upon x square tan square x. Now if you put x is equal to 0, what you will get? Tan square 0 minus 0 upon 0, because if you put x is equal to 0, it will go to 0. Now tan 0 is 0, so you will get 0 by 0 form. Now before applying Lecpitals rule, to make our sum simpler, what we will do, we will multiply and divide the denominator only by x square. So what you will get? Limit x tends to 0, tan square x minus x square upon x square into x square tan square x upon x square. Right? So we have multiplied and divided by x square. Now we know limit x tends to 0, tan x upon x will be equal to 1. So substitute 1 in this. So finally what you will get? Limit x tends to 0, tan square x minus x square upon x raised to 4. Now if you put x is equal to 0, so you will get 0 by 0 form. So start applying your Lecpitals rule. So you will get limit x tends to 0, derivative of tan square x will be equal to to 10x. Now apply chain rule, and derivative of 10x will be sec square x. Derivative of x square will be 2x, and derivative of x raised to 4 will be equal to 4x cube. If you put x is equal to 0 in this, what you will get? 0 by 0 form. Now what we will do in the next step? We will replace sec square x by 1 plus 10 square x. So on replacing, you will get 2 10x into 1 plus 10 square x minus 2x upon 4x cube. Now open the bracket and take out 2 common and cancel it out. So finally you will get limit x tends to 0, 10x plus 10 cube x minus x upon 2x cube. Again, if you put x is equal to 0, you will get your 0 by 0 form. So simplify further by applying Lecpitals Rule. So do the derivative of the numerator and denominator separately. So what you will get? Derivative of 10x will be equal to sec square x. Derivative of this will be equal to 3 10 square x. On applying chain rule, you will get sec square x minus 1 upon 6 x square. Right? Now sec square x minus 1, we know it is equal to 10 square x. So you will get limit x tends to 0, 10 square x plus 3 10 square x into sec square x upon 6 x square. Right? Now take out 10 square x common. So what you will get? Limit x tends to 0, 10 square x into 1 plus 3 sec square x upon 6 x square. Now again we know limit x tends to 0, 10x upon x is equal to 1. So this will go to 1. And if you put x is equal to 0 in sec, we know sec 0 is 1. So finally what will remain? 4 by 6. On simplifying, you will get the answer of the limit as 2 by 3. So in today's lecture, we have studied firstly the forms such as 0 by 0 form, infinity by infinity, infinity minus infinity, 0 into infinity, 0 raised to 0, 1 raised to infinity, and lastly infinity raised to 0. So these forms are known as which type of forms? Indeterminate forms. Now, firstly, we have studied the working rule to evaluate 0 by 0 form, and it is known as Lecpitals Rule. Right? So, what is the rule? So, let me specify the rule. Limit x tends to a, f of x upon g of x will be equal to limit x tends to a, f dash of x upon g dash of x. So you have to do the derivative of the numerator and denominator separately and eliminate our indeterminate form and find finite answer of the limits. So in today's session, I hope you understood everything. Thank you for watching.